When we think of entertainment, we usually don't think of school subjects like math or physics or maths, as we say on the other side of the pond. But why shouldn't they be entertaining? In Project 2, Resources for Entertainment from the Advanced Communication Series Manual, the entertaining speaker, Lloyd Smith, will entertain us with the explanation of one of the most important equations in physics. So he says, F equals M times A. Lloyd Smith and Joe Smith.
It's a nice summer day in the summer of 1939, and the San Francisco Seals minor league baseball team is playing a doubleheader. The team's owner had to dream up a publicity stunt to draw in the crowd, which is the case of a lot of minor league baseball teams. And he's hit on a good one. In between the two games, the Seals catcher, Joe Sprints, goes out into the outfield with his catcher's mitt. At about the same time, a blimp comes gliding over the stadium. When it's at about 800 feet, the team owner's son leans out one of the windows and drops a baseball. The idea is that the crowd will see Joe Sprints try to catch a baseball dropped from 800 feet in the air. As the ball comes down, Joe has to move around. It's because it's pretty breezy in San Francisco, even during the summer. He hones in on the baseball, though, and it gets closer and closer to him. When it's about 2 feet above his head, let's push the pause button to think about a couple of questions. First of all, is it possible for him to catch it? Now, every baseball catcher, even high school and little league catchers, is used to the idea of dealing with pop-ups. That's when the batter hits the ball straight up in the air and they have to run underneath and catch it. But this is an 800-foot pop-up. That's higher than the Space Needle. So can he do it or not? The second question is, does he really want to catch it? This is a baseball coming from 800 feet in the air. And so it's likely to hit him pretty hard. Now this is the point where Isaac Newton comes into the story. Not Isaac Newton, a baseball player, but Isaac Newton, the genius, one of the greatest geniuses in human history. Newton, in the summer of 1687, spent a lot of time thinking about gravity and motion and whatnot, and he came up with the 3 laws of thermodynamics, and he also came up with the law of universal gravitation. In between those, he had to invent calculus in order to solve some of the equations that he developed too. This is not the kind of guy you expect to see sitting next to you in a regular math class, sitting up kind of above you. Newton figured out that gravity, the force of gravity, is directly proportional to the product of the two masses that are attracting each other and inversely proportional to the distance between them. This is the time you want to look thoughtful and go like this, like you did in all your college classes. He also thought a lot about force. Think about this real world example for a minute. If I walk over to Eric and drop a bowling ball into his hands from, say, about 6 inches up, he'll easily catch the ball. I mean, it's heavy, but he'll get it. But if I get up on a 10-foot ladder and drop that same bowling ball onto his hands, he might find it very difficult to catch the ball. Now, something's going on here because it's the same bowling ball, weighs the same either way. So it must be the force of gravity pulling it toward Eric that makes it hard to catch. And indeed it is. What Newton finally figured out is that the force with which something hits, say the ground in the case of gravity, is the product of the mass of the object times the acceleration that's being imparted to it. Now, baseball hasn't got a lot of mass. It only weighs about 5 ounces. But gravity is a pretty powerful force, and that's because the Earth is really big and it's good at pulling things toward it. It turns out that centuries of observations have proven that gravity's acceleration is a constant. It's 32 feet per second squared. What that means in the real world is that when something falls, in the first second that it's falling, it falls 32 feet. It doesn't matter what the thing is. It can be a feather or an axe, and it'll fall at 32 feet in that first second if you leave out air resistance. In the second second of its fall, it falls 64 more feet. In the third second, it falls 96 more feet, and so on. So it's accelerating as it goes. Now, it doesn't accelerate forever because there's air resistance. It turns out that in the case of a baseball, because of its size and shape, it maxes out at about 95 miles an hour. And what happens is that it accelerates up to that, and then the drag on it caused by air resistance equals the pull caused by gravity, so it doesn't accelerate anymore. It doesn't stop. I mean, it keeps going at the terminal velocity that it reached. So, back to Joe Springs. He's standing there with a catcher's mitt. The ball has traveled 800 feet in about 5 seconds, and it's going 95 miles an hour. He's, in effect, looking at a Felix Hernandez fastball coming straight down on him. Okay? Is this going to have a good outcome? No, it's not, and I think you can probably figure that out. He actually caught the ball, and for a split second, he probably felt really good about that. But then the ball smashed the mitt into his face, where it broke his nose, dislocated his jaw, and knocked 4 of his teeth out. Thus experimentally verifying Isaac Newton's theory of how force equals mass times acceleration. Now, what does this teach us? Well, don't do something stupid like that. Although in 1969, another professional baseball catcher actually broke that record by catching a ball dropped from 1,200 feet in the air. He was wearing a catcher's mask when he did it, though, so he didn't smash his face, which happened to poor Joe. Joe never made the major leagues, although I'm not sure whether it was his stupidity that prevented him or not, or maybe that failure to breathe through the broken nose. But what this does show is something interesting. It is possible to dream up entertaining examples to teach boring science lessons. How many of you vaguely remember force equals mass times acceleration from high school or college classes? Yeah, very vaguely. I can remember Mr. Nettleton standing up there droning on while all of us dozed off when I was in 9th grade. But there's no reason why serious things can't be entertaining too.
Thank you, Lloyd. Once again, we have a minute to write down our feedback. Timer.